single problem that has that type of thing.
So we simply mentally think, okay, I'm going to apply the ddx operator to this half and the ddx operator to this half. So when you apply the ddx operator to this half, what rule are you going to mentally use first?
The additive one?
Yep. So I'm going to find those two derivatives separately. So when I apply the ddx operator to this, what rule are you using?
The product rule?
So product rule says you take the second,
Mm-hmm.
you multiply by the derivative of the first.
Mhm.
So what would the derivative of the first be?
Would be 2x.
Perfect. Then we say plus the first, and the derivative of the second would be dy over dx,
Which is y prime,
which
right?
is y prime, and minus, and the derivative of this is,
-3.
so we're good there. What else got from listening question? Cool. So then you just go to the other side, derivative of this.
Is that 3y prime squared?
No.
So I guess this
So what rule are you using?
the power rule.
Power rule says derivative of something to a number.
So would it be 3y squared?
Closer. Let's bring down the n. We have the something. And minus 1, but the last thing is we must multiply by what?
The derivative of
Of the something. Yep. So apply that rule to this.
So you have y to the third, so then you have 3 y to the second, y prime. Oh, I see. When you do it normally, the dx over dx just equals 1, so you drop that part.
Drop is a really bad word. We should
Well-
put that right next to cancel, but
Yeah, you ignore it. because
Oh, no.
It's time. If it's dx over dx, it's 1. So
There
you
we go.
ignore it. That's what I was trying to say.
ignore is even the wrong word. What's really happening is you'd simply have 3x squared multiplied by 1, which is just 3x squared. Yeah. So no, that's what I meant when I said you didn't use the rules any differently. You
Yeah.
just have to apply them correctly.
So I think where I went wrong was, one, I don't think I used the product rule on the first one. I think I tried to do it with the power rule, and then it just didn't work, right? And then didn't understand how the y cubed, how you found the derivative of that.
Gotcha. So we got this far. We might as well finish so
Yeah.
the video watchers don't feel like they didn't get to see the end of the movie. So what we do now?
Now we plug in -1 and 2.
Oh.
Oh, sorry, no, that's not what you do.
You actually can. There's nothing wrong with that, but I do prefer that you rearrange first,
And-
just so you're better prepared for the problems where you have to rearrange. So.
Okay. So yeah, we need to combine like terms, right?
More of like group them. But.
Yeah.
So what do you want the next line to say?
Let's see here.
Glad to see Reagan's using their new erasers.
Trying to figure out where I want to go with this.
All right.
I think trying to get like all the y primes on one side, correct? So I think you subtract x squared y prime to the 3y squared y prime.
Fair enough. So tell me what's right.
So y 2x minus 3 equals 3y squared y prime. minus x squared y prime. And then divide by 3y squared, so you get 2xy.
Let's stop right there. So we got to talk about that because you're proposing that I commit a felony, which I prefer not to. Jokes are pretty bad today, as always. So you're saying to do this. Yes?
Yes.
Okay. So you can only divide factors. Is
Oh,
3y
yeah.
squared a factor of this numerator?
No.
No. So I cannot take that step. If I can, it doesn't help anything. So what do you want to do instead? Like your brain is telling you the right thing, because your brain is saying, I want to divide the 3y squared.
Yeah.
And you're also probably thinking, I want to divide the x squared,
Mm-hmm.
which is fine, but are they factors of this expression? Is 3x squared and x squared a factor of that black box?
No.
Tell me when you're ready, Michael, I'll bring it to you.
I'm ready right now.
So, no. But you can do something to make them factors. So as Avery said, this is our next step. So David, what are the factors of the right half of that black equation?
You have y prime and 3y squared minus x squared.
Good. So now you can divide by that factor. And that factor will divide to make 1 squared, sorry.
So then you get 2xy minus 3 over 3y squared minus x squared.
Yep. So now you have a formula for computing y prime. And just to make the video more valuable in preparation for the retake,
We do the y equals mx minus x1 plus y1, right?
let's talk about that for a minute. What's the purpose of this equation right here?
Of the one that you're erasing over right now.
Yep.
It is to find a y coordinate given any x coordinate.
Or vice versa?
Yes.
Good. What's the purpose of the brown y prime equation we just created?
It is to find the slope at any point.
Nicely done. What are they asking for in this problem?
They're asking for the slope at the point 1, negative 1, comma 2.
Good. So we don't need that equation of a line because they're not asking for it.
Oh, I see.
So what's the difference between the brown and what I'm now writing in purple?
The brown is the equation to find the slope at any xy pair, and the purple is the equation to find the slope at the coordinate pair negative 1, comma 2.
Nicely said. Like very well said. Outstanding, no less.
So it's negative 7 over, let's see here, 2 squared is 4, times 3 is 12, minus, let's see, that's 1 there. It's 11, negative 7 over 11.
Questions from anyone?
Okay.
Anyone have a different question from the retake that you would like to, sorry, from the test that you would like to talk about, or does anyone have a different